Hello, everyone. In this lesson, we will cover Task 2 of Project 1, the wiring diagram and data types of the S7-1200PLC. The target results to be achieved through the study of this task include: 1. Master the working principles of PLC input and output interface circuits. 2. Recognize the differences between CPU 1214C DC/DC/DC and AC DC/RLY interfaces and be able to draw their wiring diagrams. 3. Master the data types and addressing modes of the PLC. 4. Understand the principles of binary, decimal, and hexadecimal counting, and be able to convert between these systems. The knowledge structure of this task comprises 3 parts. The first part is the PLC input interface, focusing on whether the main module is powered by AC or DC, and distinguishing between syncing and sourcing input connections for digital inputs. The second part is the PLC output interface, focusing on the differences between relay outputs and transistor outputs. Relay outputs commonly drive relays, solenoid valves, and contactors, while transistor outputs can drive 24 volts DC loads and control servo and stepper motors. The third part is PLC data types, requiring an understanding of PLC addressing modes and the composition and conversion of binary, decimal, and hexadecimal data. Let's begin our learning by explaining the S7-1200PLC input interface circuit. Generally, PLC input interfaces include 3 sections: power input, digital input, and analog input. Power input is divided into 2 types: 24 volts DC supply and 22 volts AC supply. Next, we will focus on the working principle of the digital input interface circuit. As shown in the diagram, a digital input interface circuit typically consists of 4 parts: the drive power supply, input terminals, optical coupler, and internal circuit. The power supply is external to the PLC. When the input switch is closed, current flows from the positive terminal of the power supply to the input point I0.0 through the optical coupler, light-emitting diode, and common terminal 1 megohm, back to the negative terminal of the power supply. The LED is the input status indicator on the PLC panel, lighting up to indicate signal input at that point. The S7-1200PLC output interface comes in 2 types: relay output and transistor output. We first explain the working principle of the relay output interface. When the logical operation in the PLC control program energizes the coil of Q0.0, the internal circuit energizes the relay coil, closing the contacts. At this time, output point Q0.0, the external load, power supply, and common terminal 1 megohm form a loop, and the load starts working. The PLC output loop requires an external drive power supply to power the load. The output point Q0.0 only acts to close the circuit and does not provide power externally. Relay output interfaces can drive AC or DC loads, with a wide voltage range and strong load capacity, with a rated load current of up to 2 amperes. Next, we explain the working principle of the transistor output interface. When the logical operation in the PLC control program energizes the coil of Q0.0, the internal circuit turns on the optical coupler and the transistor VT, forming a loop with output point Q0.0, the external load, power supply, and common terminal 1 megohm, causing the load to operate. The main advantage of the transistor output circuit is its suitability for high-frequency actions, with a short response time of about 0.2 milliseconds, capable of outputting high-frequency pulses for position control. In the second part, we explain the wiring diagram of the S7-1200PLC and peripheral equipment. For the AC, DC/RLY type PLC, the interfaces include 4 main sections: power wiring, digital input terminal wiring, analog AI input terminal wiring, and output terminal wiring. Here, we focus on the wiring of digital input and output terminals. The DI inputs of the 1200 PLC support two wiring methods, sinking input and sourcing input. Sinking input, also known as common cathode configuration, as shown in the diagram, involves connecting the common terminal, 1 megohm, of the PLC input terminals to the negative terminal of the DC power supply, with the positive terminal of the power supply connected to the PLC input point through an external switch. In the sinking input configuration, the signal voltage at the PLC input points is a high level of 24 volts. In practical applications, proximity switches are often used as PLC input signals. Proximity switches can be PNP or NPN types. In the common cathode wiring method, a PNP proximity switch should be used, as shown in the diagram. The blue wire of the proximity switch connects to the DC 0 volts and common terminal 1 megohm, the brown wire to the DC 24 volts, and the black wire to the PLC input signal, connecting to the input point I0.0. Next, we explain the sourcing input, also known as common anode configuration, where the common terminal, 1 megohm, of the PLC input terminals is connected to the positive terminal of the 24 volts DC power supply. Select the NPN type for the proximity switch, as shown in the diagram. The blue wire of the proximity switch connects to the DC 0 volts, the brown wire to the DC 24 volts and common terminal 1 megohm, and the black wire to the PLC input signal, connecting to the input point I0.0. In sourcing input, all PLC input points need to connect to 0 volts low-level signals. The 1214C output interface has 10 output points. Since this model has relay outputs, every 5 output points form a group, creating a loop through 1 leader and 2 leaders. Note that each group of outputs requires an independent external power supply to power the load, which can be 220 volts AC or 24 volts DC. Loads are usually relays or contactors used to control external devices. Next, we explain the wiring diagram of the DC/DC/DC type PLC and peripheral equipment. Its power input is connected to a 24 volts DC power supply. Digital inputs also support two wiring methods, sinking input and sourcing input. The main difference lies in the wiring of the output terminals, requiring an external 24 volts DC power supply for the load. The 3 liters plus and 3 megohms terminals connect to the positive and negative terminals of the 24 volts power supply, respectively. After connecting the output point to the load, it connects to the power supply's negative terminal to ensure the load operates. Since the output points are transistor outputs, they can only connect to a 24 volts power supply and can control external devices through relays but cannot directly drive contactors. The transistor's high switching frequency makes it suitable for high-frequency pulse outputs, used to control servo and stepper motors. Finally, let's review the content of this lesson. We introduced the wiring diagrams of different models of the S7-1200 PLC. We should focus on mastering the wiring methods of input and output interfaces. For input interfaces, distinguish between sinking and sourcing inputs. For output interfaces, choose the appropriate PLC model based on the controlled object, whether relay or transistor output is needed, and be able to draw wiring diagrams and complete output interface circuit connections. Thank you for listening. In the next lesson, we will continue studying the data types of the PLC.